Today we're going to be talking about 4.2 multiplying matrices. And the objectives that we are going to cover is by the time you get done today, you should be able to multiply matrices by hand, and you should be able to apply them to a real-life authentic situation. So, when we multiply matrices, we have to get a few things understood first. If I take matrix A times matrix B, it should equal matrix AB. And if matrix A is dimensions m by n, and matrix B has to be dimensions n by p, then matrix AB, when I multiply, is the dimensions of the first matrix, rows, by the dimension of the second matrix, columns. In other words, these inside dimensions must equal each other, or we cannot multiply. Let's try an example. If matrix A is a 2 rows by 1 column matrix, and matrix B is 1 row by 3 columns, since the inside measurements 1 by 1 match, I should get a 2 by 3 matrix, which means I take the rows of the first by the columns of the second. Whenever I start multiplying, then I would make myself a little map. Since it is a 2 by 3, that means I need 2 rows with 3 columns. So I make 6 blanks. What I'm going to multiply by is row 1 by column 1, row 1 by column 2, in the third position, row 1 by column 3, in the next position, row 2 by column 1, row 2 by column 2, and row 2 by column 3. And a key to multiplying is to let our fingers do the walking. So I'm going to take these fingers and I'm going to point to row 1, column 1. So if I multiply row 1 by column 1, I get XR in my first position. The next position says row 1, column 2. So I'm still on row 1, but now I need column 2. So it is X times S. XS would be my next element. To get row 1 times column 3, my hand is still pointing to row 1, but this time to column 3. So I have X times T, which gives me XT. Then if I want to do row 2 by column 1, now I'm pointing to row 2 and column 1. I have Y times R. So I get YR. Then it is row 2 by column 2. So my fingers are at row 2 and column 2, which would be Y times S, which is YS. And my last position will be row 2, column 3. Row 2, column 3 will be Y times T. That would be YT. We always multiply our rows by our columns, and we take the sum of those products. But in this case, I just had one element by one element, so I should just get one element out. I have nothing to add. Let's try another one. This time, we're multiplying matrix A times matrix B. So go ahead and write down matrix A. It is a 2 by 3 matrix. And it is 4, -2, 3, 0, 1, -1. Multiplying by matrix B, which is a 1, 2, 3 rows by 1, 2 columns. And it is 1, 5, -3, 2, 0, -4. Let's check if these inside dimensions match. So can I take a 2 by 3 times a 3 by 2? The answer is yes, so my result would be a 2 by 2, where I look at the rows of the first by the columns of the last. So that is a 2 by 2. So I'm going to create my little mapping so I know what to multiply. 1, 2 by 1, 2. Row 1, column 1. That is what position this is located in. This position is row 1, column 2. This element is in position row 2, column 1, and this element is in position row 2, column 2. So when I multiply, and I will need to see this work here. Some of you may get to a point where you no longer need the mapping, so I just need to see this work. So again, I'm going to let my fingers do the walking. I need to use row 1 by column 1. And I am going to use my highlighter as well to help you out. This would be row 1, make it a little bit fatter. Row 1, and we're multiplying it by column 1. So when I do that, I get 4 times 1 plus -2 times -3 plus 3 times 0 I'm going to move these out a little bit because I obviously need a little more room to do that. Then it says row 1, column 2. So this time I'm still taking row 1, but this time by column 2. So when I multiply that, I get 4 times 5 plus -2 times 2 plus 3 times -4 and then I'm ready to move to my next element, which by my map says take row 2 times column 1. So now my fingers need to move to row 2, column 1. So I would take 0 times 1 plus 1 times -3 plus -1 times 0. And for my last element, it is in row 2, column 2. So I will still take row 2, but this time I will multiply it by column 2. So I have to move my fingers. So I have 0 times 5 plus 1 times 2 plus -1 times -4, which gives me, let's actually do this multiplying and fill in our elements. 4 plus 6 plus 0 is 10. Then I have 20 minus 4 minus 12, which is 16 minus 12, 4. And then I have 0 minus 3 plus 0 is a negative 3. And finally, 0 plus 2 plus 4 is 6. So my resulting matrix is 10, negative 3, 10, 4, negative 3, 6. Okay, let's see. Can we multiply B times A? In other words, can we take a 3 by 2 times a 2 by 3? Let's check. Do these inside dimensions fit? The answer is yes. So my result would be a 3 by 3. So then I need 1, 2, 3, 2, 3, 1, 2, 3. So this time I am taking row 1 of this matrix by column 1 of this matrix. So row 1 by column 1. So I have 1 times 4 is 4. Plus 5 times 0 is 0. This is in row 1, column 2. So still row 1, but now I'm multiplying it by column 2. So I have 1 times negative 2 is negative 2. Plus 5 times 1 is 5. And this position is row 1, column 3. Still row 1, but this time I'm multiplying by column 3. So I have 1 times 3 is 3. Plus 5 times negative 1 is negative 5. This element is row 2, column 1. So now I move my fingers to row 2 by column 1. So I have negative 3 times 4 is negative 12. 2 times 0 is 0. Row 2, column 2. Still row 2, but this time column 2. And I have negative 3 times negative 2 is 6. Plus 2 times 1 is 2. Row 2, column 3 is the next position. Still row 2, but this time by column 3. My result, negative 3 times 3, negative 9. Plus 2 times negative 1, negative 2. Final row, row 3, column 1. So I switch to row 3, back to column 1. My result, 0 times 4 is 0. Plus negative 4 times 0 is 0. Row 3, column 2. Row 3, column 2. And I have 0 times negative 2 is 0. Plus negative 4 times 1 is negative 4. Last position, row 3, column 3. Row 3, column 3. And I have 0 times 3 is 0. Plus negative 4 times negative 1 is positive 4. So my result is 4, 3, negative 2, negative 12, 8, negative 11, 0, negative 4, 4. So it's going to take some practice, and you're going to have to use your fingers, and you're going to have to move them and touch your products and write them down. So let's go back here a sec. When I take A times B, is that the same as taking B times A in matrices? Did I get the same two matrices? No. So matrix multiplication is not commutative. That is one of the only operations that you cannot do, or one of the properties is commutative property of matrix multiplication. That is not possible. Okay? This time we have matrix C, which is 8, negative 5, negative 1, 2, times matrix D, which is 4, negative 3, 0, 1, 2, negative 6. First check your dimensions. This is a 2 rows by 2 columns. And matrix D is 1, 2, 3 rows by 1, 2 columns. Do these inside dimensions match? No, they don't. So it is impossible to multiply these. And the reason why is because if I would start to take row 1 by column 1, I would have 8 times 4 plus negative 5 times 0 plus nothing else there to fill in. So I can't keep going. That is why these inside dimensions must match, or it will not be possible to even multiply. All right. Let's do A here just to give ourselves a little more practice. Let's first take A plus C. So if I take A plus C, what's my resulting matrix? 2 plus 0 is 2. Negative 2 plus 3 is 1. 1 plus 2 is 3. And 4 plus negative 1 is 3. Can we take matrix B times this resulting matrix? And let's see what we get. Let's check our dimensions. Matrix B is a 2 by 2. This resulting matrix is also a 2 by 2. So if I pull out these inside dimensions, and what remains is still a 2 by 2. So that would be 1, 2, 3, 4. Row 1 by column 1. So on this one, I have row 1 by column 1. So row 1, 0 times 2 is 0. Plus 1 times 3 is 3. Next, I have row 1, column 2. Oh, is it going to let me move that one? Well, I'll just make it a different highlight color. Let's try this one. Column 2. So I have 0 times 1 is 0. 1 times 3 is 3. Then I have row 2, column 1. So negative 3 times 2 plus negative 2 times 3. And lastly, row 2, column 2. Negative 3 times 1 plus negative 2 times 3 is negative 6, which results in 3, 3, negative 8, negative 9. And if you actually do multiply BA and then add BC to it, you get the exact same result. So what that shows us is that matrices are applicable to the distributive property. So basically, all properties work except commutative when we're talking about matrix multiplication. And one last problem. 2 lacrosse teams submit equipment lists to their sponsors. The women's team needs 5 sticks, 15 lacrosse balls, and 16 uniforms. The men's team will need 8 sticks, 22 lacrosse balls, and 17 uniforms. Each stick costs $55, each ball costs $6, and each uniform costs $35. So let's use matrix multiplication to find the total cost of the equipment. All right, so I have set up that I need a 2 by 3 because I have 2 teams with 3 items needed. And then I am going to multiply each item by the one cost it has. So if I do the women's and then the men's, this will identify my first matrix. And this will be the sticks, the balls, and the uniforms. Women, 5 sticks, 15 balls, 16 uniforms. Men, 8 sticks, 22 balls, 17 uniforms. And I'm going to multiply that by sticks, balls, uniforms, the 3 pieces of equipment, by each dollar value. 55, 6, and 35. So then I am going to take row 1 by column 1. So first let's check our dimensions. This is, oh, we already did. So we know we're going to get a 2 by 1. 2 rows, 1 column. So then I have 55 times 5 plus 15 times 6 plus 16 times 35. And then I have row 2, column 1. So row 2 will be here by still column 1. So that gives me 8 times 55 plus 22 times 6 plus 17 times 35. And then when you figure out your results, what should we end up with? $925 for the women's equipment, and $1,167 for the men's. Okay, you can spend the rest of the time practicing.